So now Jan already had a short introduction, but yeah, Catrin Granbom, and I'm the research director and heading up the research area Compute and Software for Ericsson Research. And today I will talk about the 6G as part of the AI Compute Continuum. And I think this talk fit very well with what you have started, the presentations, your presentation. So, what you can see here and what we want to say with this is that we want to show the waves of innovation. And what we can see is that for every G we have, it has come with an innovation. Or we could say that we start with 10 kilobits per second to 10 gigabit per second. Or you can look also at the timeline here. We started 80, and now we work towards 2030 and 60 cyber-physical interaction. And when I look at this picture and also the timeline, I realize, as I said, I have been here at Ericsson for 38 years. I started at Elmtel, the Ericsson and Telia's research company, 87. So it seems that I have been part of the whole journey, and also I now had the opportunity to work towards the 6G. And during the years, I have mainly worked in the software and hardware, close to hardware, and I have worked with a lot of products, product development, and then I have moved more and more to research. And as I said, today I'm heading up the research for compute and software. And I have met a lot of people that has been, that's in software center and worked with them from the beginning. And I have Magnus here. We have worked very close together during the years. Yes. So, if we start with this, so, or maybe I can say something more before. Can I do I can go back. Yeah, I will say something more. So, if we look at the digitalization, we can see that the progress. We can see that the digitization will progress and it will extend into new domains, as also what Jan mentioned in the beginning. And it will bring to a lot of new opportunities for learning and knowledge creation, new business innovations, improved efficiency, and of course also a more enhanced quality of life. And that will result in that things, people, activities will come together in a domain of intelligence and data. But how do we shape the 6G for this evolution? And it's not only to add new supporting functionality and improve the communication capabilities. It's also a lot of other requirements we need to meet. A sustainable society, and we also need the digital interaction wherever needed. And of course, we also need resilience, privacy, secure communication, and also that we need to interact with the ecosystem of AI and cloud. So, if we look at this, and what we say that the digitalization relies on the rapid evolution and convergence of the AI and mobile and cloud technologies. And we see that 6G is built to enable this convergence. So we see a dependency of the AI, mobile and cloud. And if you start with the AI, it go very fast, what you mentioned. And we have a generative AI, now we have agentic AI, and we go towards the physical AI, where machines and the real world bring together based on the AI. And the physical AI will execute on the cloud compute and will be connected via the network. If you look at the cloud, it's very stable. Applications run in the cloud. But also the cloud technologies will be the infrastructure for AI and mobile technologies. For the mobile part, there we see that the mobile networks are the glue that put the AI applications and cloud together with the connectivity. And of course also that we see the interaction between all of them, and that the mobile network will become a platform beyond the connectivity. This is an example of a use case where all the three technologies come together. This is an assistant, AI assistant on smart glasses. And that is not this one, but, this is a new UA type, very small form factor, and it has a limited compute and battery. But if it's used in everyday life, it requires a high degree of mobility and smooth handover. And it also will generate a lot of data that needs to be processed very, very close to real time. I don't know if it's someone that have these glasses already. No? No. But what is the demands for these use cases, and how can the network support? And we know that some of the application they have a very demand on this low latency and also very fast response. But other complex compute tasks, they need more, need the offload of the compute, because you don't have the compute here, you need to offload it somewhere else. And then we had the bandwidth requirements, and especially in the uplink, because if you go down and a lot of the information, and that could explode if it's very widely used. And there we're talking about something we call differentiated connectivity. And this is also both for uplink and downlink. I think that you are expert in maybe in differentiated connectivity, Magnus. Yes. So this is, it's more of them, but this is some of demands. This shows some figures from the last mobile report in November, and it's more to show the increase of the bandwidth due to the AI application. And we can see in the short term, it doesn't impact so much, because we will not have so many people that use it. But if we go a little bit further, midterm, and we have this AI assistance, and we have also it's on the smartphones and also the AR, XR glasses, of course, it will increase the bandwidth. And in the long term, with the physical AI, with all audio and video data, it will be a lot. So, how do we address this increase of the demand of this bandwidth? There we see that we consider networks to become a platform, and that offers service to the applications. And if you look at the left side, the transport data for anything, anywhere, and there we see that we will offer services as network APIs to allow the applications to program networks, to provide right compute capabilities. And if you go to the other side, we see the net 6G platform as the platform that will be go beyond the connectivity, and we can see the platform as the source of data, or the network as a part of the AI Compute Continuum. And when we talk about the AI Compute Continuum, it's like offering compute and AI services, etc., for the application on top. So, 6G AI Compute Continuum. This is a focus on the value proposition that it can bring to the distributed AI applications. And as you can see here, it goes from the mobile devices to the core network. But robust, secure and differentiated connectivity, as I have been talking about, efficient access to compute and AI, access to network insights, optimize data transfer and handling, manage AI models and dynamic optimization of connectivity, compute and AI, and also an overarching demand and data sovereignty and privacy. What I can say here is that what we are doing today, we do research on all this and work on this. And I don't know, Magnus, are you working on some of it, maybe? Yeah. Mm. Yeah. So, and what you can see also in the other side here, that what we see that 6G platform supporting multiple stakeholders. So it's something, if I go back to your speech, Jan, this is something, yeah, that build up what you were talking about. Yeah, so we can do all these fantastic things. So I will sum up with this. And now you look at it. Yeah. So we believe that the 6G platform will be will bring the physical world and the digital world together. So in the cyber-physical world, the 6G platform will offer or deliver services and meeting needs and requests. And also, it will be possible for new evolved use cases from this. So I think this is the AI Compute Continuum. So this is what we're going to tell you. I hope it was something new.
Sorry?
I hope it was something new.
Absolutely. No, you will stay on stage. We're going to ask a few questions. Could you go around with, could you grab the hand microphone so we can have some questions from the audience? I hope you understand that what Ericsson actually provides is an incredibly innovative infrastructure that, as I think Magnus already identified, all of you as companies are able to build solutions on top of. Yeah, and I know that, you know, people said, oh, 5G just gave me a little bit faster 4G. But I was discussing with some people in Ericsson at some point, and they said, you know, every time we go to an odd G, the technology innovation is significant, but the business innovation is not really there. And then when we go to an even G, yeah, that's when the business is actually being created. So I think at Ericsson, everyone is looking forward that for 5G, maybe it was mostly technology and not so much use cases. But for 6G, damn it, here's the money. So what is the thinking here? Are there any questions concerning 6G and where this will take things? If there's a microphone here, if you could.
Thank you. Michał Pałka, Volvo Cars. One of the factors behind the success of 4G and 5G is the fact that it's completely transparent for the app developers. So if someone is developing an app for a mobile phone, they don't really care whether it's 4G, 5G, or Wi-Fi. They're just using it as a transport layer, right? It's completely transparent. Will this change? Do you think that this will change for 6G, or will it be still completely transparent?
Maybe I will let Magnus answer. He's the best to answer.
I got the look.
Yeah, because he's
I'm not an expert on everything, but I'm partnering with Catrin, and we can perhaps respond to your question. If we look at what you said, that today the network is a transparent data pipe, and that is a concern for Ericsson, because then we are deep down in commodity, and we cannot do so much about your service experience. Part of what we try to achieve is to open APIs to your applications, such that we can provide you a superior experience when you need it. For a few times, of course, but complementary to that, we try to analyze what you're actually doing. So even when you're not aware of that we optimize your data flow, we try to perceive to give you a superior experience, depending on what kind of traffic you do, what is your actually latest requirements for your application. And you can either tell us, or we have to guess. And we try to open up APIs so you can tell us. And if you don't tell us, we try to understand what you do. And for that, we do use AI.
Yes. And if I can pick up on that, okay, thank you very much. That was a great, she wants to think back. As a quick follow-up on that, I thought I had a question while you're all thinking of your questions, because we still have a few minutes to fill here. So let's be creative now. You showed us the glasses, and I think that that's a beautiful use case, because it is physically impossible to insert all the compute and intelligence in the glasses themselves. So there you must have compute in the network in order to be able to have the experience that you want. Because if you go too far away to a cloud server sitting somewhere else, the latency will be such that you will get really either car sick or annoyed or whatever it is, right? I mean, I have a VR.
It takes a long time to get the,
exactly.
the response.
So you're physically forced to offload compute to the network.
Yeah.
But I'm wondering, where are the use cases where it is simply cheaper to offload to the network? Because I'm looking at the amount of compute that a Volvo Cars puts into its vehicles is quite significant. It's not cheap to put that compute in there. So if you could offload to the network for certain use cases, so you could have less hardware in the car and use the network part because it's a more cost-effective solution, not because you're physically required, but because it's a more cost-effective solution. Also uses less of the battery power in the vehicle. I'm just mentioning another factor here. I mean, what I'm looking for is, how should we reason about those kind of use cases where it is simply more economical to put the compute in a network? Does that make sense?
Yes, of course. I think that's, but yeah.
Yeah, so I'm trying, because I mean, in the case of the glasses, you don't have a choice.
Yeah, I think.
But here you have a choice.
Yeah, but I think we always try to identify new use cases.
Right.
So that's something.
Yeah.
And that is maybe we also need more help from others to really help us to identify that.
Yes.
So-
and then Jon Lans. Oh, sorry.
Yeah.
Peter was first. Yeah, so we're streaming, but Peter was first. So Peter has the first use case. You have the
My
second
name
use
is
case.
Peter Thorngren from Volvo AB, and I'm doing drone teleop and automation for heavy commercial vehicles. The main limitation I see with these things is that we are really poor on our ability to develop the systems because we don't just have the place to do it. I'm struggling enormously to have somewhere to develop the systems. The test tracks we have today or even don't have 4G in many cases. So there is an enormous need of coming together to enable this type of technology hands-on. If you're really good at spending time in offices and doing a lot of gyro tickets, that's really well developed. But actual work that brings real value is not really happening.
But if I answer, I think I understand, because it's I think all companies feel that. How do we find, where can we try out, where can we try, to develop this and whatever. And at the moment, I can see one thing that maybe will help all of us, I hope, is this Vinnova application that has been we work on at the moment for a digital test center for Sweden, a national test center, where we try to put together everything what we have already invested in, not and it's several companies, but also academia that is part of this. And it's start with to build new services and find a solution on the 5G, but we also look forward in this test center for 6G, how because it's still time before we have it, but you could be as an early adapter. So that, I think this is an initiative from Vinnova to come to the next step, so we really can start to do this together, and that will be a national test center.
Yeah. But I think what Peter is looking for is how can Software Center help on that front too?
Yeah, but you can be also involved in that, So.
Because, I mean, I'm not sure if you've heard what Peter just said. He feels that you have to be out of the test track and do real things instead of file Jira tickets, because Jira tickets. And if John can get the microphone as well, so you can just imagine how he feels about researchers that are not even filing Jira tickets, but are just sitting there writing papers, right, Peter? So, and with that, thank you for the comment. Jon?
Yes, just a thought here. Jon from Volvo AB as well. Have you reached a point where physical limitations, limit you for 6G, 7G, and blah, blah, blah? You can't make it faster for everyone. So we reach a point where we have to look sort of sideways. You have to pay for your bandwidth. In that, I mean, for CPUs and sort of, we have also reached a situation where it levels out. Are we there, or will you improve it for everyone? Because that's not a pessimistic question. It is sort of, then we have to look for other ways.
How far are we from the limitation?
Yeah, the physical limitation.
That was a very tricky question. I think I need to ask the expert again here.
That's for me again. Sorry. But I diss you for a bit. I go back to the Jon question first. Your question was actually the same as, why do we use cloud computing?
Yeah.
And that is a matter of scale. If you have tasks that you do very seldom, why own the compute for them?
Yeah.
So if you can offload them to somebody who can aggregate, then there is a business of scale. But then you, of course, need to have access to that compute when needed.
Yes.
And that is the challenge so far, that we build best effort networks. Most operators build networks that are on best effort.
Yeah.
We can provide them with higher availability, but you, me, others tend to not want to pay for it.
I'm Dutch.
Yeah, you're Dutch. There is in Sweden, we talk about this from Jönköping and thereabouts, and they ask, why so pricey?
Yes.
But then we have the guys from just east of here and Västergötland, and they say, why
So cheap.
no? Why to pay?
Why to pay it all? Okay.
Why to pay it all? And that's most of us. At Ericsson, we are looking at this. Can we improve availability? And then we talk about network resilience and redundancy, and we try to improve on that. So we should be present when needed, 24/7, 365, or 52 perhaps. So we try to address that so that you can offload more to the network.
Yes.
But now the question that John had,
Yeah.
are we reaching the physical limitations of network?
And the physical
bandwidth
limitation of
upgrading?
networks is there is a scarce resource. For us, that is called spectrum. So far, we are getting spectrum as we asked for. Others complain, why should telco have all the spectrum? There is still spectrum to have, but it is a fight. Why should the 3G, 4G, 5G, 6G have the spectrum instead of Wi-Fi? That is a fight. So we got the 6 gigahertz spectrum. Wi-Fi did not. So far, we haven't reached the ceiling. But this cost of deploying, at every location, you only have installed so much compute capacity. So from a business perspective, we have a limitation, not from a technology perspective yet. So if there is business driving presence, there is technology to support it.
It was a mean question.
Yeah.
With that, we are out of time. Cecilia will take your microphone. And I would like once more to thank our keynote speaker, Catrin Granbom. We have a few small tokens
Oh, yeah.
so of our appreciation. It's not really to really reimburse you for your time, but we're
Thank
very,
you,
very
thank you.
grateful for doing this.